In my previous video, I've discussed about the power formula of integration. And now in this video, I will be discuss to you about the formula you should know in integrating. So using the power formula of integration, we can, as I said in my previous video, we cannot find the integral of a function which has a power of -1. So as I said in the previous video, if we are going to integrate u raised to -1 du, using the power formula, it would be equal to u raised to 0 over 0, which is undefined. So therefore, we need other solution for this kind of problem. And that is I will be discussed to you this time. So the formula that can be satisfied to answer this kind of function is this formula said that the integral of any quotient whose the derivatives of the denominator which is equal to 1 is equal to the numerator is equal to the logarithm of the absolute value of the denominator plus an arbitrary constant. So this is our formula that can be solved. The equation whose the power is equal to -1. So let's have some examples. So for example, if we ask to find the integral of 1 over x dx. So as you can see here, our u here is x and the du here is 1, which is equal to the numerator. So therefore, the integral of this quotient is equal to the lateral logarithm of the absolute value of the denominator, which is x, plus an arbitrary constant. So for another example, we are going to integrate 2 dy over 3y minus 4. It would be equal to, so our u here is equal to 3y minus 4, and if we differentiate this function, our du here is equal to 3 dy. So as you can see here, the derivatives of the denominator, which is 3y minus 4, and the derivatives of this denominator is equal to the numerator, which is a constant. So therefore, we can use the formula that I discussed to you, the logarithm formula of integration. So our dy here is equal to du over 3. So let's change the function for easily integrate. So by isolating the constant outside the integral sign, we have 2 integral of dy, which is dy is equal to du over 3, and our whole thing here is equal to u. So it's become, by also isolating the constant in the numerator, which is 1/3, it's become 2 over 3 integral of du over u. So now we can easily integrate this equation. So we have 2 over 3 integral of du over u is ln of the absolute value of u, which is the denominator, plus an arbitrary constant. So by changing the value of u, so it would be equal to 2 over 3 ln of absolute value of u, which is equal to 3y minus 4 plus an arbitrary constant. So that is our final answer. So next, we have, if we are going to integrate x raised to 2 dx over x cubed plus 4. So our u here is equal to x cubed plus 4, and if we differentiate this function, we have our du here is equal to 3x raised to 2 dx. So as you can see here, we have here our derivatives of the denominator is equal to the numerator. So we can easily integrate this function using the second formula that I discussed to you. So therefore, x squared dx here, which is our numerator, is equal to du over 3. So what we're going to do is to change the function to easily integrate. So we have now integral of x squared dx, which is equal to du over 3 over this whole thing, which is equal to u. So by isolating the constant in the numerator, so we have 1/3 integral of du over u. So now we can easily integrate this function. So it will be equal to 1/3 times the integral of du over u, which is ln of the absolute value of u plus an arbitrary constant. So now let's change the value of u, which is x cubed plus 4. So the final answer would be 1/3 ln of absolute value of x cubed plus 4 plus an arbitrary constant. And that was our final answer. So next we have, let's integrate x dx over 1 minus x squared. So also, as you can see, this function also it satisfied the second formula of integration, the logarithm formula. So let's u here will be equal to 1 minus x raised to 2. And by differentiating, our du here is equal to negative 2x dx. So as you can see here, the derivatives of the denominator is equal to the numerator. So our x dx here is equal to du over negative 2. So let's change the equation. So it would be equal, the integral of our x dx here is simply du over negative 2 over this thing which is equal to u. So it would be equal to, by isolating the constant in the numerator, we have negative 1 over 2 integral of du over u. So now we can easily integrate this function. So we have negative 1/2 integral of du over u is simply ln of absolute value of u plus an arbitrary constant. So it would be equal to negative 1/2 ln, and then u is equal to 1 minus x raised to 2 plus c. That will be our final answer. So next, if we are going to integrate the function x raised to 2 minus x over x plus 1 dx. So as you can see, this function, the numerator is on higher degree than the denominator. So what we're going to do here for us to easily integrate this function is to simplify first the function. So by dividing this function, we have now x squared minus x divided by x plus 1. So x squared divided by x is simply x. Then by multiplying x times x is x squared. Then x times 1 is plus x. Then by combining, we have so it would be cancelled. So we have minus 2x. So by dividing again, negative 2x divided by x, so we have negative 2. And multiplying again, we have negative 2 times x is negative 2x. Then negative 2 times 1 is minus 2. Then by combining, so it will be cancelled. Then we have plus 2. So our new equation here is we have x minus 2 plus 2 over x plus 1. So therefore we can change this function to easily integrate this one. So we have now the integral of x minus 2 plus 2 over x plus 1. dx. So as you can see here, we can use also here the first formula that I introduced to you, which is the power formula, to integrate this function. So first, we're going to distribute the integral sign each term, which means we're going to integrate each term. So we have first integral of x dx minus 2 integral of dx plus we have a constant to here, integral of dx over x plus 1. So it would be equal to, here in this function we can use here power formula. So we add the exponent by 1, so it's become 2, and then divide the equation by its exponent, so we have 2 minus also power formula. So we have here 2, the integral of dx is simply x plus 2 times the integral of this one. So in this thing we use here the second formula. So our u here is equal to x plus 1, our du here is equal to 1 dx. So dx is equal to u, so it's simply the integral of du over u. So in simplifying, we have 1/2 of x squared minus 2x plus 2 times the integral of this function. So we have ln of u, which is our u is equal to x plus 1. So we have absolute value of x plus 1 plus an arbitrary constant. So that's our final answer. So next, if we are going to integrate a function dx, square root of x times 1 plus square root of x. So in integrating this function, what I'm going to do is to move this one function to the numerator. So we have square root of x is also equal to x raised to negative 1/2. So we have here x raised to negative 1/2 in the numerator, and in the denominator we have 1 plus x raised to 1/2. We have dx. So therefore, as you can see, if we integrate the denominator, so the answer would be equal to the numerator. So we can use the second formula, which is the integration of the logarithms. So therefore, we let u here is equal to 1 plus x raised to 1/2. So our du here is equal to 1/2 of x. 1/2 minus 1 is negative 1/2 dx. So our numerator is equal to this one. So therefore, our numerator is 1 is x raised to negative 1/2 dx. So it is equal to du divided by 1/2, or simply 2 times du. So we can change this to our original function for easily integrate. So simply we have the integral of x raised to minus 1/2 dx is equal to 2 du, and this function is equal to u. So it would be equal to, by isolating the constant outside the integral sign, so we have 2, the integral of du over u, which is equal to 2 ln of absolute value of u plus an arbitrary constant. By changing the value of u, we have 2 ln absolute value of 1 plus square root of x plus an arbitrary constant. That was our final answer. So last, we have, if we're going to integrate y minus 3 dy over y squared minus 6y plus 1. So in this function, as you can see, if we differentiate if we get the derivatives of the denominator, the answer would be equal to the numerator. So we can use here the second formula. So we let u is equal to y squared minus 6y plus 1. So by differentiating, we have du is equal to 2y minus 6y minus 6 dy. So by factoring this one, it's become du is equal to 2y minus 3 dy. So we have an equal in our numerator here, which is this. So y minus 3 dy, which is our numerator, is equal to du over 2. So we can easily change the equation. So we have the integral of y minus 3 dy is simply equal to this one, du over 2. Then over this whole thing, which is equal to u. So by isolating the constant outside the integral sign, so we have 1/2 integral of du over u. So it would be equal to 1/2 ln of absolute value of u plus c. Then by changing the value of u, we have 1/2 ln of absolute value of y squared minus 6y plus 1 plus an arbitrary constant. That is our final answer. So that is all about my video for this time. So if you like the video, please subscribe for my channel for more video.